Now we're going to take a look at an arithmetic series. Okay, a series is just an indicated sum of a sequence. Okay, so in other words, like if I have something like 1 plus 3 plus 5 plus 7 plus 9, etc., that would be an arithmetic series. It could be finite or infinite. Now, as far as a sum of an arithmetic series, if I got s sub n equals n over 2 plus a sub 1 plus a sub n, this is a sum of the first n terms. So let's find the sum of following. First example, I got -1 plus -7 plus -13, plus -73. So we have this pattern. Now let's look at this formula. Well, the first term is -1. The nth term, the last one, is -73. The problem is, what don't I know? I don't know n. I don't know how many terms there are. Okay, like I said, we know that a sub 1 is -1, d is -6, what is n? So I can't go to this formula directly. I have to go back and use the formula for the nth term of a sequence. So it's a two-step process here. Go back to that. Then we have a sub n, the last term is -73, a sub 1 is -1, n we don't know. The common difference is -6. You can see that you're adding -6 as you're subtracting 6 from one term to the next. So I have -73 equals -1, distributing out minus 6n plus 6. -73 equals 5 minus 6n. -78 then equals -6n, subtracting 5. Dividing through by -6, I got that n is 13. Now, certainly when you go through a problem like this, n has to be a counting number. You know, if it ends up being negative or has fraction to it, that's the part you know you messed up somewhere. We're talking about the number of terms. Okay, so there's 13 terms. Now I can go back and use this formula. So I got s sub 13 equals 13 over 2, a sub 1, that's -1, plus a sub 13, or that was the last term, -73. Okay, so I got 13 halves times -74, which works out as being -481. So another one. I have -9 plus -1 plus 7, all the way up to 103. It's in that same type of format. Okay, we don't know what n is. So we have to go through the a sub n equals a sub 1 plus n minus 1 times d. The last term is 103. The first term is -9. The common difference as well in this one, it's 8. You can take -1 minus -9, 7 minus -1, regardless. You can see you're adding 8 each time. So I got 103 equals -9 plus 8n minus 8. 103 equals 8n minus 17. Add 17, we get that 8n is 120. Dividing through by 8, I get that n is 15. All right, so there are 15 terms. So I have s sub 15 is 15 over 2 times -9, the first term, plus the last term, 103. This will work out as being 705. Now, you may not always have a problem in that type of format. You could have something like this. Say you're taking the sum as I goes from 1 to 11 of -5i plus 2. The advantage of being written like this in summation notation, you can see what n is. We're going from 1 to 11, so n is 11. Okay, so I have s of 11 equals 11 over 2. Now, it takes a little bit more work. There's not too much to do, but I got to figure out what is a sub 1 and what is a sub 11. Well, this expression here is a sub I. Okay, so a sub 1, you're going to go ahead and plug in 1 in for I. So I got -5 times 1 plus 2, so that's going to work out as being -3. And then a sub 11, I got -5 times 11 plus 2. That is 2 minus 55, so that is -53. And so working that out, you'll get -308.